partial derivatives. Can you see the whiteboard?
Not yet.
This whiteboard is visible to you?
No, ma'am.
Not yet. I'm just going to reshare you.
Yeah.
Just a second. Can you see now? Whiteboard?
Yes, yes. Yeah, whiteboard.
Okay.
Yes.
So let us learn partial derivatives. And you remember before that we we have done derivatives only. That time we have function y is equal to fx. Okay, when you have done only derivatives, not partial. That time y was a function of x. Okay, here y was y is a function of only one independent variable. So we can differentiate it with respect to x only. But in partial derivative, we have function more than one independent variables. So if we have such kind of function like that, z be a function of fxy means two independent variables. Then we'll differentiate partially with respect to first x, then y. And these will be partial derivative. Like if we differentiate this function z with respect to x. Here in partial derivative, we don't use d. As usual, we use dy over dx, okay? But in
Yes.
partial derivative, we don't use d, we use del, okay?
Del.
So
Okay.
del z over del x. This is partial derivative of z with respect to x.
Okay.
And similarly, this is with respect to y. Okay. So let us understand this by using a function. Okay. This is standard form. Let us learn later by using some function. Like for example, we have function z is equal to having x square plus y square plus 2xy. We have this function. And we need to find partial derivative. And remember one thing, when we differentiate with respect to x, then we consider y as a constant. Okay?
Okay. So it will be same as it is.
Yeah. This will
Like.
be 2x when because we are differentiating with respect to x. So this will be 2x by using power rule of differentiation, and this will be 0 because we are taking as a constant.
Constant.
Are you
Okay.
getting? And
Yeah.
this will be 2y because 2 and y are constant, and differentiation of x is 1. You got it?
One. Yeah.
Yeah. So del z over del x is equal to 2x plus 2y we have. Similarly, we'll differentiate with respect to y also. So in that case, we'll get the same answer, because 2 x square will be 0. So we'll get here 2y and plus here 2 and x are constant. So we'll write here 2x.
2x. Okay.
Got it?
Yes.
So these are partial derivatives. Now let us do some more question to find second order and uh, in which we need to verify okay, I'm telling you, like for example, you have function z x cube plus y cube plus 3x square y plus 3 x y square. We have this function,
Hmm.
and we need to find second order derivatives of this function. So let us do first order with respect to x as well as with respect to y. So del z over del x will be 3x square plus,
Zero.
yeah, 0. Okay, I'm taking 0 plus 6xy and plus 3y square.
Okay.
Got it? Yeah.
Yes.
Or we can write 3x square plus 3y square plus 6xy. This is del z over del x. Let us differentiate it again. Del square z over del x square. We'll get here 6x plus 6y.
Zero.
Yeah, 0
Um,
and 6. Y only. Got this?
okay. Yeah.
And now let us differentiate the function with respect to y. Then we'll get here 3y square, 3y square, 3x square, okay, and 3x. Sorry, 6xy. Are you getting?
6xy. Yeah.
Yeah, 3y square, 3x square, and 6xy.
Hmm.
That is right. So 3y square plus 3x square plus 6xy. Now let us find second order derivative with respect to y. We get here 6y,
6y plus 0 plus 6x.
yes, plus 6x. But in partial derivative, we find second order derivative in this way also. You know, like first we differentiate uh, this del square z over del x del y can be written as uh, just differentiate derivative with respect to y again with respect to x. Okay,
Okay.
first of all, yeah, and also we need to find when they'll ask us like we need to find second order derivative, then we need to find them also. Del square z over del y and del x. That is, sorry, del x, not z. Del over del y and del z over del x. So let us do. So let us differentiate it, this one with respect to y. Okay. To find del
Hmm.
square z over del y del x. You got it? Or shall I explain you anything if you want?
Uh, this one I got it. Yeah. Means
Okay.
now we have to solve this, right? Uh,
Yes. So we have del z over del x. Let me. Okay. 3x square plus 3y square plus 6xy. Okay. 3x square plus 3y square plus 6xy. And we need to differentiate it again to find del square z over del y del x. Now we need to differentiate it again with respect to y. Then obviously we'll get 0 here and 6y and plus 6x. Okay, del square z over del y del x. And we have here 6x plus 6y. Similarly, let us find second order derivative of this del z over del x is equal to When we differentiate it with respect to y, then obviously we have 3y square plus 3x square plus 6xy. Now, sorry, with respect to y. Now we need to differentiate it again with respect to x. So this will be 0, 6x and plus 6y. So we have 6x plus 6y. We have maybe they are equal or not, like maybe they are equal or not, but always we'll find these derivatives equal. I'm telling you which. These. Okay? You will get always equal them.
Okay.
Yeah. Now you got partial derivatives, right?
Hmm.
Now you got it? Partial derivatives. How can we
Yes.
find partial derivatives? Okay, all right.
Yeah.
Now let's start partial differential equation. Okay, our main topic. If you want to ask anything, then I'll repeat it.
Yes,
Or
ma'am. I got it.
everything is clear? Okay.
Yeah.
Partial differential equation. What is it? Let us understand. An equation which contain function function of one or more variables with sum of its partial derivative is called partial differential equation. Okay. So an equation which contains function of one or more variables along with sum of its partial derivative, and that is called partial differential equation.
Okay.
And let us learn notation. And in short, we say PDE. So let us know notation in PDE, partial differential equation. So partial derivative with respect to x is denoted by a small p, and that is hmm, uh, let z be a function of two independent variable. Then let us learn notation. Small p is equal to partial derivative with respect to x, and small q is equal to partial derivative of z with respect to y, and r is equal to second order derivative with respect to z,
With respect.
and s is equal to second order derivative of z with respect to x, and y both together. And t is second order derivative of z with respect to y. Because as I told you, del square z over del x del y is equal to del square z over del y del x. They are equal, so we can use same notation. Okay.
Okay.
So first topic is in your syllabus, formation of partial differential equation by elimination of arbitrary constant.
Hmm.
This is first topic. They didn't use this word formation. They use this partial differential equation by elimination of arbitrary constant. Maybe they didn't use this formation,
Yeah.
but meaning
By
is same.
eliminating arbitrary constant.
Yes, formation of partial differential equation by elimination of what it mean. Let us understand by using an example, because we'll use instead of arbitrary constant, we use these terms p, q, r, s, t instead of
Hmm.
arbitrary constant function. Okay, so you will understand well by using an example. Okay, uh, there is some noise like in lane. So can you hear me, or shall I mute this for some time? Give me
Yeah, I mean,
okay.
huh.
They are passing, so it will take 1 2 minute, 1 2 minute maximum.
Okay.
Okay. So let us understand this by using an example. We have function z is equal to x plus a whole square plus y minus b whole square. And we have here a and b arbitrary constant. And we need to eliminate them and
Okay.
form partial differential equation. So as we know, in partial differential equation, we need derivative. So let us find derivative of z. So del z over del x will be 2x plus a, and del z over del y will be 2y minus b.
Okay.
Correct? So, and we know that notation small p is equal to del z over del x, and q is equal to del z over del y. Let us put here, okay, in this equation. So, p is equal to
Two
2x plus
x.
and q is equal to 2y minus b. And from here x plus a is equal to b by 2 and y minus b is equal to q by 2. And we need to put now these value in the given function here, okay, to eliminate arbitrary constant. So let us put. So z will become p by 2 whole square plus q by 2 whole square. Or we can write as z is equal to p square by 4 plus q square by,
Hmm.
or either we can write here also, or you can simplify more, p square plus q square by 4, and 4z is equal to p square plus q square.
Two square. Okay.
Okay, yeah, and this is the lowest form. Okay, after that we can't simplify further. So even you can write this answer or this one or maximum till this, and which is required PDE.
So this is the partial differential equation.
Yes.
Okay.
And question was here. Actually, I took only function. Uh, Question is form a PDE by eliminating arbitrary constant A and B. Mm, constant A and B. I'll give you this question, okay? On WhatsApp also. You got it?
Yeah.
Shall we do one more question?
Okay.
What do you say? What do you say? You got this, or shall we do one more?
Uh, one more from the same
Okay,
type.
sure. Sure, sure. We need to form PDE. Question is find PDE of hmm, for the following function by eliminating arbitrary constant a, b, c. And we have this function. We have function in this way: x over a plus y over b plus z over c is equal to 1. Now let us differentiate, because z is a function of x and y. So we need to differentiate
Okay.
this function with respect to x and with respect to y.
Yeah.
And also we can write this z over c is equal to 1 minus xa minus y over b. Or you can write it as also z is equal to c minus c over a into x minus c over b into y. Okay,
Okay.
you got it? Yeah.
Yeah.
Now we need to differentiate it with respect to x and with respect to y. So let us do. So del z over del x is equal to 0 minus, and we have here only minus c over a. Okay,
Hmm.
minus c over a, and this term also 0. So obviously we can write it directly also. Shall I?
Yeah. So P is minus C over A, right?
Yes. And del y over, so del z over del y is also minus c over b. So p is equal to minus c over a. Okay. And q is equal to minus c over b. Give me a moment. Actually, one more condition in this question I'm mentioning you here. Actually, they have given to us find PDE of all planes having equal intercept on the x and y axis. Okay, and
Hmm.
so we have this equation of plane here. Okay, and they told us actually. Okay, do you remember like geometrical formulas? Not yet. Like equation of circle, equation of like straight line and plane, curve. Do you remember?
Yeah, yeah. Some.
Yeah. So they told us here, I'm writing you here clearly. Mm, okay, I'm sending you this question, then you'll understand this well. Instead of writing, I'm sending you this. Because sometimes they'll give you such kind of question, they'll not give you any function, but they can give you in this form also. If you have any past paper or any like any question or any pattern you have, then you can share me so that I can give you practice material according to that. We have this question. See, okay. So they are saying that find PD of all planes having the equal intercept on x and y. So I was just using as usual, okay, for this function. You got it now?
Which one, ma'am?
This question I have sent you. Actually, we are using for this.
Hmm.
See, on
Okay.
WhatsApp, I have sent you.
Find the PDF of all planes having equal intercepts on the x and
Okay.
y axis.
So
Okay.
this is the required equation of plane.
Hmm.
Okay. And what we need to do here, they are saying that we need to take equal intercept on xy axis. So that means we have A is equal to B. Are you getting?
Because it is of equal intercept.
Yes, exactly.
Okay.
That
Hmm.
is why. So in that case, we can take P is equal to minus C over A and Q is equal to also we can take the same. So if we take this equation 1 and this equation 2, so we can conclude that from equation 1 and 2, 1 and 2, we can take P is equal to Q and this is required PDE. You got it?
Hmm. Okay.
Yeah. So you got this or shall we do one more? What do you say?
Yeah, I got it.
Okay. So is it enough for today for demo?
Yes, ma'am.
Okay, I'm telling you where you can find this saved whiteboard and recording of live lecture. Um,
Okay.
yeah, I'm sharing you screen so that you can find this. See, here you can find the recording, okay? And in
Okay.
study material section, you can find the saved whiteboard.
Okay.
Okay,
Okay.
yeah. So you'll do on Tuesday and Thursday and Sunday, right?
Yeah, ma'am. I'll,
Yeah, your mom told me about the, yeah. Okay.